I'll give another minute for some people to come on. I was late posting the link today. I got caught up with something else and slipped my mind until a few minutes ago, so I posted it. But today's lesson is not bad. This is actually one of the easier things that we're going to do for a while. Today and tomorrow are pretty easy. So, actually the whole week isn't that bad. Hopefully you enjoyed field day yesterday, however that worked out. Alright, I'm going to go ahead and start because it's getting recorded. They can watch it later, and it's pretty simple. This is not going to take 40 minutes for you to do. So this is a Pythagorean theorem today. Pythagorean theorem states that for right triangles, so your triangles have to be right triangles. So if you had a triangle, it would be right triangles have that little 90-degree angle to it. So it has to be right triangles. So double check to make sure it's a right triangle first. This isn't going to work for any other triangle but right triangles. And it is a formula. So you just plug into this formula and solve. That's all you're doing. Plugging into this formula, solve. And it is an easy formula that we've actually gone over already this year. It's a squared plus b squared equals c squared. This is the Pythagorean theorem. Note on your triangle, A, B, and C are specific sides, kind of. Well, basically C is a specific side. C has to be your longest side, which will be opposite the right angle every time. And we call this the hypotenuse. I'm going to misspell that. I'm going to look up the spelling for that. Hypotenuse. So this is C. C is always going to be the longest side of the hypotenuse of your right triangle, and it's always going to be opposite the right angle. So you can see how this side is opposite the right angle here. A equals a leg, and B equals a leg. This could be A, and then this would be B, or you can have it set up so this is A, and then this is B. They don't matter which one's which, as long as one of them is A and one of them is B. And C has to be your hypotenuse. So always remember that C is the hypotenuse. So it's really simple. They'll give you two of these, and they will ask you to find the third. And you do that by just using that formula. So let's go ahead and look at our first example. Let's say that, I don't know, C is 30 and this side is 15. And we want to know what this side is. So we'll say it's X. So then you go ahead and assign your variables. Well, this one has to be C because it's the longest side. This one could be A or B. I'm going to call it A, and I'm going to call this one B. Then you just plug in to your formula, just like you normally do with formula work. We have A squared plus B squared equals C squared. A squared would be 15 squared plus B squared equals C squared, which would be 30 squared. Then you just solve. Go ahead and use your calculator if you get bigger numbers. I don't know why I chose these bigger numbers, but I did. So 15 squared gives you 225 plus b squared equals 30 squared gives you 900. Subtract 225 from both sides, and you get b squared equals 900 minus 225, 675. Now keep in mind this is b squared, not b. So this distance here is b, not b squared. So you actually have to solve for b squared as well. So we're going to take the square root at the end. And that's going to be b equals whatever the square root of 675 is. And we're getting an approximation of 25.98. Somewhere around there. You can sit there and find your perfect squares out of that. I don't know if 675 is clearly divisible by 25. So that is, so if we want to get a better answer, 675 is equal to the square root of 25 times the square root of 27. 27 has a 9 in there. Square root of 25 times the square root of 9 times the square root of, what is that, 3. And then this is 5 times 3 times the square root of 3. So 15 square roots of 3. Just double checking to see if that makes sense. And that does. That gives you the same answer. So you could leave it as that as well. So b here equals 15 square roots of 3. This is the stuff we did last week. My face is in the way, isn't it? Yeah, my face is in the way. Let me delete my face here. This here is the stuff we did last week, just simplifying your radical. If you want to leave things under the radical, you need to simplify it. If you're going to give me the approximation, you can just do it on your calculator. But that's how you're going to get b. Now let's look at the theory behind this, I guess. So how is this equation derived? Right, you have your right triangle, and we can, I don't know how well I can make boxes sideways, but you'll note that we have a square here. We'll have a square here, and this square is not going to be nice. I'll do it that way. You should have a square coming off here. Now my squares are not perfect because I'm not perfect, but this here would be b squared, like the area of this. I'm writing. So this is b squared. That's the square of b. That length is b, and this length is b. So b times b is b squared. This would be a. This length is a. This length is a. That would be a squared. This would be c. This length would be c. This length would be c. This would be c squared. And if I added up these two areas, so the fill of this area and this area will equal the fill of that. Oh, that wasn't connected. The fill of this last area. Yeah, there's a little piece there that's missing. So this area plus this area will equal this area. And that's really all it's saying. Pythagoras really didn't come up with that either. He's just credited for it. Which one is preferred? What do you mean which one is preferred? Oh, I guess for answer-wise, it doesn't matter. I would leave it under the radical just to give you some practice simplifying. Let's do another example here. Let's do an example in black here so I can see it. Let's do an easier one here. What if we had a triangle that looked like, again, let's say this is 9 centimeters and this is 12 centimeters, and we don't know this length here. Right? So first off, it's a right triangle, so check. We can use Pythagorean Theorem, which is a squared plus b squared equals c squared. We know that our legs have to be a and b, so I'm going to go ahead and label them. It doesn't matter which one's which, and we know that our unknown has to be c. So here we're just going to fill into our equation. A is 12 squared plus b squared is 9 squared plus c squared. Again, you can probably solve some of this in your head. 144 plus 9 squared is 81, and that equals c squared. So 144 plus 81 gives us 225, which is equal to c squared. And again, don't lose your squares. Okay, so this here is c squared, not c. This is c. So we want to take the square root of this and the square root of that. So c is going to equal the square root of 225, which is 15. And that is in centimeters, so your answer will be 15 centimeters. X equals 15 centimeters. Right? Not too difficult. You just plug into the formula and solve. It's going to depend on where your unknown is, if you're going to do some algebra or just kind of normal arithmetic. Because the first one we had to do some algebra, this one, if I can find another one. What if we had 8 miles long there, 4 miles long there, and it asked for that one. So what if we had something like this? This is a B, not a 6. Right? Again, same thing. A squared plus B squared equals C squared. Plug them in. We'll call this A because that's already called B. And we'll call this C. That's an A, not a 9. A squared is going to be 4 squared plus B squared we don't know, plus C squared is 8 squared. 4 squared is 16 plus B squared equals 64. Here you got to do a little bit of algebra, get B squared by itself. So minus 16 on this side, minus 16 on that side. You're going to get B squared equals 64 minus 16. 64 minus 16, I'm just doing to get it's 48. So the square root of B squared is equal to the square root of 48, which means B equals the square root of 48. And again, that's not a perfect square, so you can either reduce that radical or use your calculator to estimate it. Using the calculator, this is going to be approximately, the square root of 48 is 6.93 if I rounded it. But again, you can also reduce the radical. So the square root of 48 is equal to, looking at it, do we have any perfect squares that go into that? You do, you have 16. So the square root of 16 times the square root of 3. So that is 4 square roots of 3. And just double check that we reduced that correctly. 4 square roots of 3 is still giving us that 6.93-ish. That's simple. The problems for your homework today are on page 587. You're doing 1 through 12. It does not give you, well, it gives you a triangle, but it gives you the generic triangle. Like for number 1, it's going to just tell you that A equals 6 and B equals 10. Therefore, you want to find C, just because that's the one that's missing. And then you just plug into A squared plus B squared equals C squared. And it's really that simple. a squared is going to be 6 squared, plus b squared will be 10 squared equals c squared, so 36 plus 100 equals c squared, so 136 equals c squared. Take the square root of both sides. Square root of 136 equals c. Either reduce it or use your calculator to get a better answer. Let's reduce this one first. 136 is, let's see, 36. I'm not sure what this is going to work with. It also might not even be reducible. I don't know. We'll find something. Definitely goes with 4. So the square root of 4 times the square root of 34. I don't know if 34 can be reduced at all. Yeah, it might be the end. Square root of A equals 6 and V equals 8. For V? Oh, yeah, it does. Sorry, the answer is 10. It looked... we'll still solve this one. We'll just call this example. There is another one in here. I'm just trying to find it. 34 divided by... I think there is. Square... I don't know. Let's just check it this way. The square root of 136. We should be getting approximately 11.66. This is going to be 2 times the square root of 34, which equals 2 roots of 34 is actually, no, that's it. Or you can go with this. So it's this or this, either one. Let's actually do number 1 now, because it'll give you a nice round answer and you won't have to worry about your square root things. But let's actually do number 1. Thanks, Adam. Here you have A equals 6, B equals 8, and it wants you to find C. So again, A squared plus B squared equals C squared. A squared is 6 squared plus 8 squared equals C squared. That's 36 plus 64 equals C squared. 36 plus 64 is 100 equals C squared. Square root of that, and 10 equals C. That one worked out nice because it was a perfect square. But that's it. So give it a go. And try it out. Let's see what you guys can do. And if you have questions, bring it tomorrow or send me an email. With that, I hope you had a great field day. Tomorrow we're going to do something very similar. We're going to do, so tomorrow we have distance, which is really the same thing. And we have midpoint, which is, you know, find the distance and divide it by half. Well, get your distance to your midpoint, and then you do the same thing. So, but both of these are formulas. In fact, I even gave you the formulas there because I didn't put them on separate slideshows. But it's all formulas for today and tomorrow. And Thursday and Friday we'll do something a little weird at first, but once you realize what's going on, you've been doing it for the past month, so it shouldn't be too bad. With that, I'm going to end it. So have a good day, work on some math, work on some science, catch up on any missing work you got, and let me know if you have any questions. Bye.